I just want to explain how complex number fits into our number system. Now, basically, we've really only worked with real numbers, and we've never really looked at imaginary numbers. So real numbers is basically where you have all the numbers that we've already been working with, like 3 decimals, rational numbers, irrational numbers, recurring decimals, okay, that's a rational number as well, percentages, all these are real numbers. Now, the real number system is, like you have all different types of real numbers. So you can have, rational and irrational. And then in the rational number system, you can also have integers, counting numbers, they're called natural numbers. Like counting numbers, integers include -2, -1, 0, 4, 5. So they include negatives. Irrational, by the way, is 2, e, pi. Rational is anything that can be written as a fraction. So these are like 0, 1, 2, because they're numbers you use to count. Whereas imaginary numbers, they result when you have, say, x squared. You've got an equation, x squared equals -1. And when you square root the -1, you get I. Okay? Even something like this, -9. So when you square root -9, you get root -1 times root 9, and we replace the -1 with an I. Root 9 is 3, so it's just 3I. So you have in imaginary numbers, and with your imaginary numbers, you can still have imaginary numbers that are rational and irrational, the same as we can with the other system. Now, a complex number is a combination of a real and imaginary number. So it's in the form of A plus IB. So you have a real part. So you have a real part and you have an imaginary part. So I'll just call this Z. So that means that real Z would be just A, and imaginary Z would just be the B. Now, if B was equal to 0, then that complex number would just be A, which is a real number. And if A was equal to 0, then Z would just equal B, IB, which is an imaginary. It is purely an imaginary number. So for a complex number to be purely real, that means the imaginary part of that complex number would have to be 0. And for it to be purely imaginary, the real part of Z would have to be 0. Okay. So if we draw a big diagram of this, the complex number, which is A plus IB, would be all of the numbers. That's like the big terms, like the universe. Okay. But then it can go into 2 sections, the real part and the imaginary part. So the imaginary part is just like IB, and the real part is just A. So the real part is where B equals 0, and the imaginary part is where A equals 0. Now, within each of these parts, like within the real part, you have rational and irrational. Okay, so you have surd, pi, e function, and then you have 3, 2/3, 4%, 1, 0, -4. Okay, that's rational and irrational. And similarly, in the imaginary, you could also have a rational imaginary number, and you could also have an irrational imaginary number. Okay, like I root 2, or this one would be 3i. Okay, so once you've looked at rational and irrational, the irrational, like if you're looking at the rational numbers can then be like integers. And integers are like, -2, -3, 0, 1, 2. They can include negatives. And you could also have natural numbers or counting numbers. And the natural numbers are like 1, 2, 3, 4, where you can count. Some of the letters that go with this, like C is for complex numbers, R is for real, I is for imaginary. Integers are Z, and if you want positive integers, then it's like Z with a plus next to it. And I think N is your natural number system or your counting numbers.